Hopefully I am live. I'm not sure if anybody is around. But yeah, we'll start working with this. The last two Thursdays I missed it. One was because of a family thing, and then there was a power outage last week. This is actually the second time that I'm trying. I'm not sure. The Makerville weekly Hangout number 3. So let's just get into it. So yeah, the idea is the last two Thursdays I missed it. The last two Thursdays for family thing, and then there was a power outage last week. Right. Okay. Yeah. So what I'm going to do today is take the Valtrack board and add Zephyr support for it. This is going to probably be easier than I think because ESP32C3 support already exists. So if I go and say West boards, I get a list of all the boards that are supported. Let me just increase the size, and then I can just grab C3 in here, and we can see there's like 3 ESP32C3 boards. I think there's 2 Texas boards that grab caught here as well. But basically there's 3 C3 boards already. That means people have added support for C3 development boards. That means there is support for the C3 chip in Zephyr already. So the hard part's already done. I actually have one of those boards here with me. So you can see this is actually the stamp C3 board from M5 Stack. I'm not sure how visible this is, but it's like a tiny C3 board. It's like probably a little more than an inch tall, and I have it connected here. So just to check out, what kind of stuff is here, I'm going to just build and flash this, right, so that I know that I have all the dependencies that are needed for building C3 based development boards installed. So all the tool chains and everything that this requires. So let's just run hello world. I'm going to do a pristine build. That means anything that I have from my previous builds is cleaned up. So yeah, this is a little different because this is I think one of the first boards from SPSF, which is RISC-V based. So it's probably going to have a different tool chain, different tooling to some extent, but yeah, it's going to be slightly different than your regular ESP32 boards, which are based on Extensa from Cadence. So this might need some different things. So just to verify that I have everything, I'm going to do this, and it looks good. Can then just do West flash. Okay, so let me just attach this is an extra step I have to do because I use Windows subsystem Linux. So now you can see there's that, and now it's found the serial port, and it's flashing the whole 4 megabytes by the looks of it, and that's it. So now what I can do is I have to do expressive monitor, which is like a specific command for a specific board, and as you can see it says booting Zephyr OS, hello world stamp 3, and looks like it's gonna keep on. let's just take a look at the source code. Yeah, so it's gonna write hello world and the name of the board, and then it's gonna sleep and keep doing that in a loop. So hopefully by the end of this we can build this same application again, but instead of the stamp C3 board, it will print the Valtrack V4 Valtrack V4 board. So I have the Valtrack documentation open, and I have the documentation for the Zephyr open, which shows how to add support for a new board. And I did go through this earlier today. What I'm going to do is I'm going to follow that along, and let me just close this. Yeah, so what I'm going to do first is I'm going to go to Zephyr boards, right? As you can see, I'm in the boards directory, and there's a bunch of architectures that are already there. So the one that we want to look at is inside the RISC-V architecture, because the ESP32C3 is RISC-V, as we mentioned. And as you can see, there is the stamp C3, and then there's the ZAO C3, and there might be one more C3 board here somewhere, right? So let's just do something quickly. Let's just copy C3 in Valtrack. We're going to call it Valtrack. I think Valtrack is good enough because the version number can be added inside. So let's say Ravi decides to create a Valtrack V5. It could be in the same folder directory potentially. So yeah, so let's go to Valtrack. I'm going to start one by one and edit the files and remove any references of the C3 board. Alright, so first things first, PS5. Yeah, let's just go to the kconfig board. Okay, we don't need this. This is the, okay, we can go right, Valtron, Valtrack, board combination, board configuration, yeah, these things are important because let's say there's some issues with this board, they know who to contact. And then I'm going to just write Valtrack here. We don't need to change this because we also depend on the ESP32C3 board. So yeah, this is good enough. Let's go to the next file. I'm going to just copy some of these things. Right, okay. This is Valtrack as we named it, and board depends on Valtrack again, config heap mem. Let's keep these the same. I don't think we are going to be using Wi-Fi and Bluetooth that much because the Valtrack board has a cellular modem. So this is basically configuring the heap size so that if there's Wi-Fi we have a certain amount, if there's Bluetooth we have a certain amount, so that whatever additional firmware is required when we are using Wi-Fi or Bluetooth or both, it has enough heap configured. We can still use Wi-Fi and Bluetooth on the Valtrack, I believe, but we don't need to. So I think let's just keep it here. I don't think there's any harm in having that here. this is again, I don't think something that we have to change, because the same tools that are provided by Espressif and OpenOCD, these are going to be useful when we are using the Valtrack board, and I don't see anything specific to the board here, and there shouldn't be. This is common stuff across this. Here we might have to change a bunch of things. Yeah, let's not add V4 yet. Valtrack featuring. Let's see. You know what, I'm just going to quickly change all this strings. Yeah. And I can come back to this later. This is just the documentation folder. Yeah, and this is where things start getting interesting. Right now we're just, you know, naming things, but now that you see these file extensions, the DTSI, the DTS, yeah, so these are all the device tree files, these two particularly. This is where we have things specific to our board. So for example, in a particular board, let's say the LED is on pin 12, and on the, let's say Ravi's Valtrack, it's on pin 24 or something like that. In that case, the configuration change needs to be put in one of these files, so that Zephyr knows that when someone wants to blink an LED, let's say they want to blink LED 0, what pin to look for, right? And it's not just that, it's like that's like a simple use case, but there's other things as well, because sometimes the same pin is configured to be used for two different peripherals, like you might have SPI and I don't know, CAN or something like that on the same pins. So you have to configure how you are using that on a particular board so that Zephyr knows that. So all of this is typically done in device tree files, and this is again not unique or new to Zephyr. This is actually from the Linux kernel. That's how they do things. They started doing this, I think, 15 years ago, because there was a lot of mess in the kernel because of board specific stuff, and then they're like, yeah, this is not going to scale, so they introduced the concept of device trees and device tree overlays, and that's how we have this. So it's its own thing, right? Like it has its own syntax, it has its own compiler. So actually I might have that. I think it's called DTC. Yeah, I think it's this. So there's a device tree compiler that you can install in your OS, you know, using apt or yum or whatever, and I think it's one of the requirements for Zephyr as well. I vaguely remember installing it as part of Zephyr's instructions. Anyway, so we have created our board directory. Let's just take a look at the official instructions on how to go about this. In this instructions, they are creating a board called Plank. So wherever you see Plank, it's actually Valtrack for us. So yeah, there's a bunch of files that we need to edit, which is what we're doing. And yeah, we already edited the kconfig.board. We also edited the def config, and let's see what else. Board.cmake. Where's the def config? Yeah, it's there. Just strange. There's a kconfig.def config and there's a plank underscore def sock. This is interesting. This file is not present in this particular board. Let's take a look. Some of the it's there. Yes, this is the def config. All right. So this is one that we need to edit. So config board. Again, we change this to Valtrack. This is the same. Let's keep this the same. All these other things should be the same. Maybe we might need some more things here based on the hardware, but the idea is to first get it, in a place where I can toggle a GPIO, get serial, and then we can add the other hardware that is specific to the Valtrack board. The reason I say that is because we mostly will have to add support for those extra hardware by adding device drivers, which is a whole different thing. So for example, let's say you put an accelerometer on your board, then you add the device driver for that in a separate place, and you have the board files for a development board in a separate place, and then you just use those. That way that device driver will be usable by other people as well. So ideally we don't want any of the boards, like the Valtrack specific extra hardware mentioned anywhere here. But I'm going to rename this to Valtrack config and this to Valtrack.yaml, this to Valtrack.tts, this to Valtrack.pin.tsi. Alright. This is also same. I don't think we need to make any changes here because this is specific to the chip, and honestly I don't even want to change this to the copyright here. We're just copying stuff, so alright. Now let's take a look at this, and yeah, so first we'll have to change this. So we have to point it to the right file. Alright. Again, we need to change this to Valtrack compatible with these power states, for example, would be the same because we're using the same chip. I don't think there will be a lot of, actually this might be different because the Valtrack board is also battery powered, so I'm not sure if there's things that we can tweak here to get some more juice, but let's worry about that later. There's GPIO keys because there's a button. Again, we have some buttons here, so we'll have to take a look at the schematic later. Let's just worry about getting a hello world on here. And I think we made, like, we just copied something that works and made the necessary changes. Let's go back. Let's go back and see if we can see the Valtrack board. And yes, now if I say west boards, you'll see that we have the Valtrack board here. So let's say if I was supposed to run this, and instead of stamp C3 I write Valtrack. Let's see if it builds. It feature idle build because we just basically copy pasted a lot of stuff from something that works for the C3 chip from ESP32. In the meanwhile, I'm going to start this power supply here so that we can power up this Valtrack board that I have. Perfect, looks like it's built fine. Now I need to power this Valtrack board and connect it to my computer so that we can hopefully flash something on here today. Perfect. I heard the familiar sound of your USB connecting. That means the ports on here. Is this thing that I extra have to do? I'm just gonna do that. 3, 2. Alright. Right, let me just remove the C3 port. I don't want it confusing. Alright, perfect. And then I'm going to say last flash, and looks like it flashed, which is great. So let's I think we fucked up somewhere. I think this has to do with the size of the flash. Attempting to boot anyways. The flash boot. So basically the checksum failed, which is interesting. And well, let's take a look at what we saw before. So one thing is these things, so this SPI speed, mode and flash size, right? That's something that I'm kind of worried about is different. No, it's the same here, which is fine. Let's see what we get. Oh no, we flashed something already. Okay, so basically what's happening right now is there's some differences between the stamp C3 board and the Valtrack board, which is fine. We just need to figure out what those differences are, and then we can make changes to the device2 files accordingly. These things never work in the first go. I mean, you're surprised if they did. So it's 4 MB flash, and let's see what the specifications are. I don't think he's mentioned the flash size here. Ravid hasn't. So I think we're just supposed to take a look at the data sheet here, which is this. I don't know why I can't copy this. C3FH4. Let's take a look at the data sheet. C3FH4. Alright. So it looks like it's the same. Let's take a look at the stamp file and compare that with the dev kit, right? Let's see. The dev config is going to be the same. There's no changes here. This seems the same as well. Okay. Oh, I haven't checked the comments today. Okay, and I'm just curious where I wonder if some of the things that could be different here is the clock frequency, if it's an external one, and what else? The flash could be different. Let's also take a look at inbuilt flash. Okay, so C3FH4 has the inbuilt flash, the RAM is inbuilt of course, so that means that let's see what's happening here. Okay, so this isn't mentioned anywhere in the board files, so the chip variant is probably not an issue. What else could be an issue? Scan bitrate, okay. TTSI, deep sleep. Okay, the TTS file doesn't feel like there's much there. The UART default is on 2122. Is that right? So yeah, one thing that we can check is, so the UART 0 here is 21 and 20. I wonder if, I'm fairly certain that's the one that should be there on the Valtrack, but let's just take a look at the schematic anyways. Might be something we're missing there. Okay. This is the MCU section. I don't know why this is so bad. Yeah. Okay. But we're looking for 2021, which is interesting because, oh no, so I'm gonna have to take a look at the data sheet as well and search for 20. Okay, GPIO 20 is pin 27. Pin 27 here is 0, 0, okay. E0. UART 0 connector. Ah. What is this? So it looks like the UART0 connector needs to be connected somewhere, right? So let's search. Interesting. So if you look at this file here, so this is UART0 default. This is the only one that's exposed, but it looks like we have UART0 connector on a connector on the Valtrack boards. Like the UART0 is on a connector exposed, and the UART1 is used somewhere. Is this? That doesn't help. One other thing that could be the case is, so if you do an LSUSB, I see this as Espresso USB JTAG serial debug unit. I'm not sure what chip that is. How is this board being flashed? Is that, I mean, the Espresso board has USB built in, right? So full speed USB serial JTAG controller. So this is the part that's being exposed on the Valtrack board. I think that's for sure. What might be different is it's being done on the stamp board. Not good. Let's see if we can find the schematic of the stamp C3 board. Page. Schematic. Sorry. This sucks so much. Why do they have? Okay. Okay, so this is the schematic for the stamp board, which is working for us, and we have the device for this, and this is what we have with the Valtrack board. So if we compare, we should be able to figure out what's different and then work accordingly. So yeah, this is the top chip is C3 chip, and then this is this CH9102F, which is then connected to the U02XP, which comes from here, and then this is the chip that I'm actually talking to when I'm talking to the stamp C3, but that's not the case with the Valtrack board, is it? There is no CH340G, CH9102F, sorry. Yeah, I think I figured out what's different. The way these boards connect to your PC is different. I think one is over USB, and one for the stamp board there's a chip which probably gives it the JTAG part as well. Although I'm not sure about that. PTR, RTR. Yeah, this is quite interesting. So yeah, so these GPIO 10, 18 or 18, 19 are connected to the USB connectors, which is how we are programming the board. And here we have CH9102F. that's how we're focusing. So yeah, I think we're gonna have to make changes to OpenSD as well, because that's how the device gets flashed, and the way we flash it is probably going to be different, which I don't think is good. Anyways, I think figured out what we have to do now, and already running late for the half an hour schedule that we have. But yeah, I think we at least got it to a place where we can build the Valtrack board. We can flash it yet. We need to figure out how the hardware is connected. Right now, we have the files in place so that Zephyr identifies that there's a new board, and it will build for that particular architecture. We just need to fix the serial and USB parts that are there in the OpenSD config, and mostly in the device config as well. So we can do that in the next one, or probably do an extra session this week to get this out. Cool. Yeah, I should probably take a look at the flow of this as well, just to make sure it's not something related to that. I don't think it would be. Yeah. Anyways, guys, thanks for joining. Let me know if you think there's something else that might be the case here. Just to reiterate, I could just show the log. Oh, nice. Let me just flash it again. See if they're okay. That's stopped. What the fuck? This is not supposed to. Yeah, the flash works, but when you try to read it, there's a section, and then you don't get that. Anyways, I'll do some more, and then